Hi guys, welcome to another class of Advanced Sport Nutrition. This is our last class we're going to have until our next exam, which will be the following week. This is perhaps one of the most important lectures as well because we're talking about fluids and performance. And if there's any one way to increase performance in the very short term, it's through hydration. Now, one thing to note about hydration it's a balance between how much total body water you're losing and how much you're actually intaking as well. Now, here's just a position statement on exercise and fluid replacement, is that individuals can lose anywhere from for a half a liter to 2 liters an hour. And that is a lot of water to be lost, especially as we'll see some of the mechanisms as why that's important later on. Now, again, from the same position stand, you'll notice that in many different sports, there's a disconnect between how much fluid is actually lost versus how much fluid is being taken in after the fact or even during. And you'll notice that in a lot of different sports, such as maybe basketball, athletes will sweat a lot more, but they're not getting the necessary fluids to replace that. So you guys as practitioners, you guys need to be constantly pushing hydration to your athletes on a consistent basis. So like I said, there's a disconnect between fluid loss and what's being replaced. Now, of course, that is going to also depend on the environment. Obviously, if you live or if you're working in colder temperatures, the sweat rates are much lower. However, when working in areas that are real hot, such as Florida, the sweat requirements are very, very high, especially if you're working in humid areas. And if you guys don't know, when individuals begin to sweat, if the sweat is dripping, typically that individual is not cooling off because it takes the evaporation to actually cool somebody. So if someone is dripping sweat and if that is not being dispersed amongst the air, they're actually becoming much harder, which continues the process of continuous sweating. So in areas like Florida, it's very important that you continue to push hydration. Now, perhaps one of the most one of the situations that's probably the most stressful is when you combine a hot environment with high insulation. And what that turns is you get a situation of high heat stress. Take, for instance, playing football in, say, Florida or even Texas, where it's really humid, and then you couple that with the pads. That is very problematic for football players. In fact, every year you always see maybe 1 or 2 high school athletes or even college athletes that pass away from heat stroke. And that's a very serious problem, but it's something that can be controlled. And typically the person who gets in trouble, the person they point the finger at, is the strength coach. So it's very, very important for you guys to always manage individuals' hydration levels. Now let's talk about some of the influences that has on performance, more so looking at aerobic stuff. Here we're looking at a study by Yoshida, and notice here you have levels of dehydration, and this is in percentage. Look at this associated changes in performance in the step test based off 2% hydration. And it seems that anywhere above this 2% dehydration level, you get exponential losses in performance, as it's been shown right here. And what causes that exponential decline? Well, let's just take a look at some of these parameters here on these figures. On the top one, you have stroke volume. If you guys can remember, stroke volume is the amount of blood being pumped from your left ventricle, right? And we're also looking at blood flow on the bottom part of the figure. The more and more you sweat, you start to lose the plasma volume, or the water which makes up plasma volume. Therefore, you actually have less blood in the body. It either goes into its intracellular fluid or you sweat it out. And because there's less blood volume, that means there's going to be less stroke volume as well. And you can almost see as this is almost a near perfect relationship between the percent body weight loss compared to stroke volume as well as blood flow to your periphery. In addition, we see almost a near perfect correlation between body weight loss as well as cardiac output. But in turn, because you have less blood volume, that means your heart has to work harder to keep the same flow of blood to your peripheral organs. And therefore, you see heart rate actually goes up as well to a near perfect correlation. So in that case, it's very important to continue to hydrate during exercise. And again, this is just kind of an example. And just imagine this is your left ventricle and it's pumping heart, which contributes, or it's pumping blood. And let's say, for instance, there's less blood to fill this area. So therefore, in order to keep cellular oxidation or energy, ATP requirements, your heart's going to have to pump much, much faster to keep that, to maintain that level. Now, continuing on the same study, right? In response to that increased heart rate, we see that the ratings of perceived exertion also go up somewhat exponentially. So it's somewhat high. And notice the differences here between the groups, between the four different groups. The individuals who had lots of fluid versus the individuals who had basically no fluid. You see a difference of almost 6 points on the Borg scale. As well as, you know, when you're training in hotter temperatures, you almost see a perfect correlation between temperature rise as well as weight loss. So yet again, that just kind of tells us that the science shows that the hotter the environment, you need to be pushing more hydration practices to continue either performance based off some of these mechanisms. I mean, it doesn't take science to know that. Basically, it should be almost common sense. Now, to back up some of the data that we see in the environment, let's look at this figure to the right. This is what we call a force plot. And you'll notice that we see changes in performance regardless of the temperature, right? As you're going to continue to exercise, fatigue is definitely going to build up. You're going to lose some weight based off sweating rates. But notice the differences in performance between the cold and the hot. Obviously, the hot, you're going to sweat more, and therefore it's going to impair more performance. And this is such a big topic for us, especially living in Florida. And that basically says that the greater the temperatures, or the lower the temperatures, you can maintain your blood volume as well as your cardiac output. Now, keep in mind, this whole time I've been saying to push hydration, not necessarily water, because there is such thing as what we consider as hyponatremia. Now, hyponatremia is it's common, especially in individuals who exercise quite frequently but don't have the necessary electrolytes to continue nervous system conduction. Basically, hyponatremia is low levels of sodium in your plasma. And once it gets below 130, you start to experience symptoms. And what those symptoms result in are usually headache, perhaps vomiting. You'll see swollen hands and feet, and you'll get some kind of confusion and disorientation. Now, One thing about this, if sodium levels fall below 120 millimolars, this is very, very problematic. In fact, this can lead to cerebral edema with seizure, coma, but lastly, it can also result in death. And if you notice, I put a picture here of Marines training. And if you guys recall, I actually served in the Marine Corps myself. One thing is they always push hydration, but every year within recruit training, there's always seems to be a couple different deaths because the drill instructors will keep pushing hydration without this associated increase in sodium, and therefore individuals will die of hyponatremia. Now, let's look at hyponatremia in certain time frames. Let's say an event less than 4 hours. Now, the typical responses from an hyponatremia of less than 4 hours is a decrease in blood flow to the kidneys and also a lowered urine output. Basically, your kidneys are releasing hormones to sustain whatever water to maintain water, so you don't urinate as much. Now, one thing you want to avoid when to avoid hyponatremia is large consumptions of low sodium containing water, such as distilled water. Now, hyponatremia in other events lasting longer than 4 hours, such as like in an ultra endurance event, are a little bit different. I'll just kind of read this response out to you. Sodium losses can induce hyponatremia to levels associated with the onset of symptoms, regardless if the individual is over or under drinking. So replacing some of the sodium losses is warranted, indicating that despite whether they have an abundance of water intake or not, sodium needs to be continually replaced in individuals. So water is just not the only thing that they should be taking. They should definitely be taking in other substances as well to accommodate sodium losses and prevent hyponatremia. Again, it's very dangerous if it gets beyond that point. Now, another area where we see hyponatremia is in American football. A lot of times, football players will drink an abundance of water to prevent quote-unquote cramping. And oftentimes, it's not, if they're not giving associated levels of sodium, they also can fall into hyponatremia. So, as always, sodium needs to be continually replaced. So, in summary, there's a disconnect between fluid loss and replacement. Aerobic decrements are seen at low levels of dehydration, particularly if you're going to be exercising in hot environments. It is also essential to replace both sodium and water to avoid dehydration as well as hyponatremia. So that covers much of the aspects regarding aerobic performance, and there are more in the book that you will see in your highlights. Now let's talk about hydration and anaerobic performance. Now here's something that's quite interesting, and okay, so here's something that's quite interesting. Here's a study by Jellison et al. Let me pull that in there real quick. Jellison, and it's actually quite common study that a lot of individuals use to kind of make an argument as to why hydration is so important. Oftentimes, because strength, power, and usually strength endurance events, a lot of times because it's not so continuous, people don't really feel the onset to drink more water or continue to hydrate. But as you can see here, there are some small changes in strength, maximal power, and strength endurance. And what Jellison concluded is that typically, if somebody is 3 to 4% dehydrated for strength power athletes, strength declines roughly 2%. Maybe not a big deal. However, maximal power starts to decrease by 3%, But where it really has an impact is in strength endurance. Now, many of you guys might find that that's not really a big of an issue. However, I will say this. We master in the minors when it comes to high performance training. Therefore, it's always important to get the maximum effort out of each individual training bout and set and so forth. Now, continuing on with Juttleson's research, we notice that there's differences between both the lower body and the upper body. And notice that muscular endurance in the lower body is affected much more than the upper body. Now, but let's look at strength on the other hand. Muscular strength in 3 to 4% dehydration in the lower body isn't affected as much as upper body strength. So either way, there should always be a level to continually pushing hydration. Not so much more, as well as for the aerobic, but just as much as for anaerobic or strength power. And like I said before, the reason being is because, let's just take a look at this. Results from the last Olympic Games indicate the gold medalists in the 100-meter dash defeated the 8th place finisher by an average of only 3%. Again, we master in the minors. That small difference could be the difference between you winning or you being completely out of the race. Now, some of the mechanisms to kind of understand that, continuing on with Juttleson's research, here we have percentages of central drive, and we can measure central drive based off EMG, which is what we have in our lab, and also combining that with maximal torque or isometric contraction. And if you notice here, when a person is euhydrated or truly hydrated, we see a higher amount of force with maximal voluntary contraction, with electrical stimulation. However, with only a 2.5 decrease or percentage loss in hydration, you start to see that central drive is starting to fall off. As well as if it goes -5, it's even worse. Now, they didn't continue that, but who knows what that might be if it was in a real-world scenario, like, say, in a Florida football practice, or even in a tennis court where you're out in the sun, sweating. I'm assuming that your central drive may be depressed even more so beyond these levels. Now, some of you guys might not necessarily be into the sports realm. You might actually be more considered into the training side, right? Well, they go hand in hand. But more so just about training volume within your resistance training. Here we're looking at research by Kraft, and what you're looking at are 3 different exercises, and we're looking at differences in training volume between a hydrated and a dehydrated group. Notice that from each one of these, there is a big disconnect between each group for some of these exercises. Now, not every exercise, but notice that whenever an individual is hydrated, they're always getting a little bit effort. Again, we master in the minor, so we definitely want to push hydration for our athletes. Remember what I said, hydration is one of those ways that you can increase performance within the short term, and this is a perfect example of it. So 3% dehydration on training volume of 3 sets of 12% loads resulted in a decline of 15% total training volume. And here we're seeing it even more so on these exercises. Additionally, Despite there being less total volume of work being performed, the dehydrated group actually perceived it as much harder. And we can notice that based off the RPEs, the RPE differences. And notice that as the exercise session continues, it starts to get harder and harder as they continue. So you start to perceive the exercise as being much harder. And additionally, heart rate will go up. And that's based off the same mechanisms as aerobic. Now, another thing too to consider is velocity of contraction. Now it seems though, even though maximal voluntary contraction with electrical stimulation, there is some central drive that is being influenced by dehydrated levels. However, high velocity contractions are not seen as affected by hydration. Now that could be just because of some error. Who knows? But you would likely think that it would. But in this particular research, they didn't show that same effect. But there are some who train with controlled contractions, such as, for instance, bodybuilders, who are more specifically looking at building muscle. And bodybuilders typically use more of a slow and controlled contraction and train with very high volumes. Based off the two research papers that we've seen, if you are dehydrated, that could definitely affect your an optimal training environment. Now here's another thing to consider, which I'm not so sure we've ever covered this in any of my classes, but there is such thing as called cell swelling theory. So to speak, the pump, which what Arnold really popularized in the 70s. And essentially, the more hydrated a cell is, when I put stress on it, it compromises the integrity of the membrane of that cell. And by doing, the more and more compromise I put on that by the hydration of the cell, causes a cascade of cellular components to tell the cell to create more protein. And if muscle building is the idea, then having more of a hydrated cell is better for the anabolic response. Now here you're seeing a picture of one of my old mentors where he's actually doing blood flow restriction, and you can see how much of his cells really start to pump up. In addition, it increases the metabolic accumulation, and it draws fluid into the cell. Now here is some data that we took in my previous lab at the University of Tampa. Now what you're seeing is a muscle that's being looked at in an ultrasound. And here you see the femur, and you have the vastus intermedialis and then the vastus lateralis, basically on the side of your leg. And you're seeing the distance between the bone all the way to the connective tissue of the fascia. Here is just fat and skin. Notice during pre-occlusion, look how small it is. It's 4.42 centimeters. But once they occlude the muscle and it draws water into the cell, look how much of a difference you change from 4.42 to 5.16 centimeters. And it's a larger muscle size. Therefore, being dehydrated when training compromises some of those anabolic responses. And we're going to get into some of those later in this lecture. So, numerous studies have shown that hydration-mediated cell swelling results in an increase in protein synthesis and a decrease in protein breakdown. Now that's very important, again, for creating muscle hypertrophy, not only for aesthetics, but also in sports performance. Not only in muscle cells, but in a whole bunch of different cells, which include liver cells, bone cells, and even the muscle fiber themselves. And here's just a demonstration of how water increases the cellular volume to increase the cellular conduction from the cell membrane all the way down to its associated anabolic responses, such as the mTOR signaling pathway, which is, if you guys can remember, is the mammalian target of rapamycin, and that leads to increased protein synthesis. Also, more cellular volume, better conduction within the cell membrane itself, leads to mitogen-activated protein kinases, and then more gene expression. Research has demonstrated that changes in hydration status of the cell may be responsible for skeletal muscle hypertrophy. In addition to all that, on the other end, if an individual is becoming dehydrated, it also makes the cell much smaller. In hypertonic conditions, water is actually being drawn out of the cell, which causes them to shrink to maintain the concentration or the osmolarity within the plasma. And here are some demonstrations of that by some of the research by Patrick Finn, where as you see total body water loss, you're starting to see total body protein decrease, as indicated right here in this figure to the right. So declines in hydration status result in declines in cellular hydration and a loss in muscle protein. Let me try to fix that. There we go. Now let's talk a little bit different. We've talked about sport performance as well as muscle hypertrophy and how dehydration can affect some of these things. Well, another thing to consider when discussing hydration levels is insulin resistance. And for those of you who don't know what that means, is basically your pancreas secretes insulin. Now, along the line, whether it's through inactivity or whatever, the cells become less receptive to that insulin, and therefore insulin will be, or glucose, will stay in your systemic blood vessels for a longer time. Now that's something you don't want. You want your cells to take up that glucose as fast as possible. If it doesn't and it stays lingering, it can lead to a lot of problematic areas, such as individuals with diabetes. And it can be very problematic with tissue neuropathy, jaundice, and a number of different things. However, when it remains higher in your systemic blood, it also shunts, it depresses an individual's ability to use fat for energy. So to increase or to mediate insulin resistance, we're seeing that hydration levels actually influence that. And you're noticing here somebody who's truly hydrated or euhydrated. In this particular study, hydration, this is actually 75% hydrated and then half hydrated. You'll notice that as an individual, what they did in this particular study, they gave individuals a glucose tolerance test. And you'll notice that when an individual is truly hydrated, the insulin response is much lower and defalls much faster. However, if somebody is dehydrated, notice how insulin peaks up much higher, stays elevated for a longer time period, and then falls back closer to baseline about an hour after. Now that's pretty significant changes in that how hydration can affect insulin resistance. Same thing with glucose. One way they want to measure insulin with glucose disposal. And as you can see, they both pretty much line up with one another. Smaller insulin spikes, glucose is being disposed of faster. However, in this case, glucose isn't being disposed of, and therefore you have a higher insulin response. And one reason to think about that is because there's such thing as a GLUT4 receptor. The GLUT4 receptor will actually translocate from inside the cell all the way to the cell membrane, grab glucose molecules, and pull them back in to be stored as glycogen. Now think about that. If your inside your cell is less hydrated, that means that that GLUT4 molecule is not going to be able to move as fast. Probably because the cell is going to be seen more viscous and it can't move as well. Here's another thing is when we look at testosterone, just look at this if you're somebody who wants to increase the anabolic state of your training bouts, is dehydration decreases the anabolic response to training. So in a sense, in the same study, they actually had these individuals train and measured their testosterone responses. Now those responses weren't significant, but again, we master in the minors. The higher is always the better. So you'll see that in these individuals, the more dehydrated they were, the less testosterone response they had. Coupled with, if you were dehydrated, your cortisol elevations were much higher. Remember, cortisol is actually the catabolic hormone, and they work in conjunction with one another. You want your testosterone response to be higher than your cortisol, and in this case, cortisol was superseding that of testosterone. So in summary, dehydration of greater than 3% slightly decreases maximal strength and power, maybe -2 to -3%. However, it has a greater effect on repeated high-intensity bouts or strength endurance, usually 10% on average. Because it does this, hypertrophy training is impaired, particularly when contractions are slow and controlled. Along with impaired volume, there is a decrease in swelling response to training, and if hypertrophy is your goal, you want that swelling response. There's also a decline in anabolic hormone responses and increases in the catabolic hormone responses. That concludes this part of the lecture. Be sure you go through the highlights and highlight those areas within the book. Thank you.